So let's pick this up right where we left off. Hopefully by now you've had a chance to practice using SOHCAHTOA to solve for a lot of different pieces of right triangles, be they angles or sides. So now we're going to move on and take a look at some application or some word problems of this. So a couple things we need to go over first, just a couple of new definitions here. Look at the whole idea of an angle of elevation and angle of depression. So whenever you see an angle of elevation referred to in a problem, it refers to the angle made from the horizontal up to some level, usually somebody's eye level, or the angle for something on the ground to something up on high. But it's usually from the horizontal up to some level. Similarly, if you see the angle of depression written anywhere, that's going to mean the angle made from the horizontal down to a certain level. And to further illustrate this point, you can take a look at this picture right here. So in this situation, you have somebody looking up to a hot air balloon. The angle elevation for the person's height, for the person's line of sight, from the horizontal is 38 degrees. So you see that's the angle there with the horizontal, 38 degrees. Similarly, from the hot air balloon, the angle of depression down to the person on the ground is 38 degrees as well. You'll see that those two angles will be the same because both these lines at the top and bottom are horizontal, so you have a little Z pattern being created there. So the angle of elevation for the person to the hot air balloon is the same thing as the angle of depression from the hot air balloon down to the person. Okay, with that in mind, before we get into using a word problem, let's try and recap what you did yesterday and just try and solve this triangle. If you ever see the terms solve referring to a triangle, it means to find the measures of all the missing angles and all the missing sides. No specific unknown you want to find everything. So take a minute and give that a try first, and when you're ready to see the answer, push play. So the first thing you're going to want to solve for here, at least to me the easiest thing to look for first, is to find that third angle. It's a triangle. We already have two of the angles. We have angle A and angle C. We can find angle B relatively easily. All the angles inside a triangle have to add up to 180 degrees. So then you can quickly find angle B by going 180 degrees, subtracting the 29 degrees you have for angle A, and then subtracting the 90 degrees you have for angle C. Okay, so a quick calculation there will tell you this will be 61 degrees. Okay, and now you can work on trying to find the sides. Okay, and I'm sure you remember to label your sides here. If you're choosing to work with a 29-degree angle, then that will make BC the opposite, and the side that's 33 will be the adjacent. And then you can basically choose which side you want to solve for first. So I'm going to solve for the opposite first. And so I'm going to need a ratio that involves opposite and adjacent. That's going to be tan. So tan of 29 degrees is going to be my opposite, which I don't know. Let's just call that x, over my adjacent, which is going to be 33. Okay, multiplying both sides of that equation by 33, and get my answer to be, using one decimal place, about 18.3 units. Okay, and now you have a choice. We need to now find that third side, which is the hypotenuse. We can use trigonometry again to find it, or we can go back to middle school and use Pythagorean theorem. Because it's a right triangle, we have two of the three sides. We can use the fact that a squared plus b squared equals c squared. Now, before you go ahead and do that, I just want you to think about which one might be better to use. In theory, we have all the other two sides of the triangle. However, if you look at the one we just did, this one has been rounded. Okay, we've rounded it to one decimal place. So if we use it in a calculation to get the hypotenuse, we're going to lose some accuracy here. So our answer will be a little bit off, and we want to try and make sure we're as accurate as possible. So if we're trying to choose between two methods, and since we can in this case, we want to try to get the answer exactly. So we're going to try and use trigonometry again. If I wanted to, I could use the adjacent side with trigonometry to find the hypotenuse if I use a cosine ratio. So in this case, I can say cos of 29 degrees is my adjacent, which is 33, over my hypotenuse, which I don't know. I'll call that c. Okay, and then I can go through and start solving, multiplying both sides of the equation by c. c times the cos of 29 degrees is 33, and then divide both sides of the equation by cos 29. And you wind up with about 37.7. So again, not that Pythagorean theorem won't necessarily work, but you are going to lose some accuracy there. There'll be times where you can't avoid it, where you have to use a calculated value, one that's been rounded, to calculate something else. But If you can avoid it, do so. Try and always use something that's exact, something that's given. In this case, using the side length that's 33 to find our answer, not something that's already been rounded like this 18.3. Just keep that in mind when you're solving. Okay, so we found all the missing sides and angles. We're now done this problem. Let's try and go through a word problem now. So we have a concert spotlights placed at a height of 12 meters above the ground. We have a spotlight beam shining down an angle of depression of 35 degrees. We want to know how far the spotlight is from the stage, distance being along the ground. So take a minute and just try and sketch this out and try and set up the problem. So pause this and push play when you're ready to see the answer. Okay, let's take a look at a picture here. So there's a spotlight. Let's make that a little bit smaller here. And so with this spotlight, it's hanging above the ground, and we're going to say that's at a distance of 12 meters. And it shines at an angle of depression of 35 degrees towards the ground. Now, one thing you got to remember, angle of depression is the angle made from the horizontal. So it's not actually referring to this angle right here. It's a very common mistake to put 35 degrees here. It's actually referring to this angle right here with the horizontal. So that's the 35 degrees that's giving you. Okay, so with that in mind, we still don't have any angles inside the triangle, but we can quickly find them out in a couple ways, right? We know that these two angles here have to add to 90 degrees. So you can go 90 minus 35 to say that this one is going to be 55 degrees. Or you could use a Z pattern here to look at this one and say, okay, if that's 35 degrees, this down here has to be 35 degrees as well. Okay, and then you need to wants to find out the distance the spotlight is from the stage along the ground, so you're looking for this, so I'll call this side length D. Okay, once you have that set up, you have to choose what angle you're going to work with so you can label your sides appropriately. So I'll work with the 55 degrees. Okay, again, it doesn't actually matter in the end, but if I work at the 55, then this D becomes my opposite, and the 12 becomes my adjacent. So I have the angle, I need the opposite, I have the adjacent, I'm going to use tan. So tan of 55 degrees is D over 12. Okay, quick multiplication of both sides of the equation by 12 should give me an answer of 17.1 meters. Okay, so that's our first word problem there with trig. Let's give another one a try. Okay, so take a minute to read through this problem. We have an antenna attached to the roof of a school held in place with two guy wires. If you're not sure what a guy wire is, what essentially is you have an antenna right here, and these are two wires that are being used. They're tied from the from the roof, essentially from the top of the roof to the top of the antenna, and sort of anchoring that antenna in. So these would be our two guy wires here on each side, each of them being 16 meters. And we have an antenna that's 12.5 meters tall. Okay, and we want to know the angle the wires make with the roof of the school. So if the roof of the school is along here, the angle the wires make with the roof would be right here. So I'm going to call that angle beta, and I want you to try and solve for that, and then when you're finished, try and solve B. Okay, hopefully you've given it a try now. Let's take a look at the answer. So for the first one, if you're working with this angle right down here, the 12.5 is your opposite side, the 16 is your hypotenuse. So sine of beta is your opposite over your hypotenuse, 12.5 over 16. Whenever you're solving for an angle, you have to use the inverse function. So you're going to take the inverse sine of 12.5 over 16, should give you about 51 degrees. For B, we want to know the distance from the base of the roof. The wire should be secured. So now we're actually looking for this distance right here. So let's call that D. And again, you got some choices here. Think to yourself, would you rather use trigonometry to solve for this side, or would you rather use Pythagorean theorem to solve for the side? Which one would be more exact? So if you take a second, think about it. Well, if I were going to use trigonometry to solve for this side here, I have to use this angle beta, which I just calculated, so that's been rounded. So the more exact approach here would be to use Pythagorean theorem. So using Pythagorean theorem, I'm going to have d squared plus 12.5 squared is 16 squared. And if you take a look here, you can run through the calculations, solve for d, and you should get approximately 10.0 meters. Okay, that's it. That's all. So again, take a look at your homework here. You should have already done this day 1 stuff up here. Now we're going to focus on the day 2. Okay, when you get down to page 412, this looks like a lot, number 1 to 17. Most of these are word problems. So I'm going to give you the opportunity to pick and choose here. Read through them. Make sure you try a lot of different types of word problems so that nothing's really much of a surprise. And yeah, and then just go from there. So good luck with it, and see you guys later. Cheers.